Hello, this is HodPod back again with another one of our creations. Now, this particular device we're calling a HODCELL, HODCELL, because it's basically one cell, and it's stainless steel, and the fuel that it burns, it actually doesn't burn it. The fuel that it consumes is aluminum and water. Aluminum, water, and then a neutral carbon catalyst. And then that's heated up to, the solution is heated up to about 185 degrees. And then there's a chemical reaction that occurs and pure hydrogen comes out. And that is a known fact that's been documented, and there's patents on that. So we're just following the guidelines of Dr. Phillips with a variation of this particular device. So what I've done here is taken a 6" by 6" aluminum, 3/8 of an inch thick. This has been tapped with 5/16 national course, and I've put these bar stock into the base. So this gives me the foundation. And the surface here has been cleaned. It's been lightly sanded, very smooth, and then cleaned with a lacquer thinner. Okay. Now, the second component here is a stainless steel canister. This was purchased on Amazon.com for $12. As it turns out, from my testing against earth magnets, it seems like it's not quite pure stainless steel like I imagine. It does have some magnetic ability, but nonetheless, it'll work, and in it goes. Now, it's important to understand that there's a very good fit. So the bottom of this unit has a little indentation in it. You can probably see it right there. But it does have a very good connection area, and that's what we're going after. So we're putting this in here, and this will make an electronic connection as well as a way of transferring heat when we heat this unit up to 185 degrees, 200 degrees. All right. Now, we did also have some of this cream. I purchased some heat transfer cream, but I decided not to use it because it's more important that I have the electrical connection than the heat transfer. So that's where we went with that. Okay, so let's see. Next is a gasket, and down inside you can see it's just a stainless steel beaker. The gasket is made of pure rubber. This is a 6" by 6" material, 1/16 of an inch thick, and it's purchased at Home Depot. You can buy it in many places, and it's just used for various plumbing projects. Okay, so that's in place. And the next item on the list is the lid. Now, the lid is a combination of a few things. First of all, this material is a special kind of plastic. I unfortunately forget the name of it. Maybe I have it here. Hang on. Yeah. Oh, Garolite. 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 1/2 inch thick. So this is Garolite, which is a little more expensive, but its heat rating is higher than Lexan, and also acrylic is tough to work with and shatters. And this stuff was a dream to work with. It worked great, easy to drill and shape. Now, when I did receive it, I saw that it was slightly warped, so it was not absolutely flat like I imagined. So I did have to work on it by using sandpaper on the bench right here. And I just kind of attached a little bit of sandpaper on the bench, and then I leaned into it and went back and forth several hundred times in order to flatten it out so that I have a perfect seal. Okay, now in the center I have a stainless steel tube. This is 1 3/4 inch stainless steel. I did a pretty good job of positioning it dead center over a hole, and I had to weld on a piece. This is just a a 560. Let's see. Let me make sure. 532nd. Right. Right. Yeah. 532nd. It's a 532nd stainless steel bolt, and I cut off the head, and then I did my welding. And I'm, do not have a Heliarc or any kind of advanced welder. I just have a very inexpensive welder, so I kept having to put more and more beads on it until I finally got it. So it's not the best weld. However, it worked. So that is positioned, as you can see, so it floats dead center. And then I used goop, which I've got this amazing goop. It's good stuff. And I put a couple of drops of that on the bolt and the washer, and then cranked it down. It does have a nut in there as well, as to give it a square fit on the back end. So that's been gooped, so it's watertight. And then on the top side, I drilled a hole and then tapped a quarter NPT for a hose barb, and so that's in place, and I got a really good seal on that. I cranked it down real tight. I also have on the top, you can see my electrical fittings. So that's the one that connects to the centerpiece, and I'll be finishing that off with a wire. And then here is the thermometer, and again that is a 5/32 hole. It's exactly the size of that thermometer probe, and so I got that in, and again goop on both sides. Got a really airtight connection. Okay, so then this unit slides down into position, and let's put that down. Very nice. Okay. Where's my holes? There they are. Okay. All right, we're in. There. So that's a very good fit. Taking a look at the seal. Yep, looks like everything's in alignment. I may just scooch the pan over just a little. There it is. That looks pretty centered, and it's on my mark, on my little black circles. Okay, so we have a canister that is in place, and it's being sandwiched by some 5/16 threaded bar stock, and it has a thermometer on top. I just put a fresh battery in that thing, so it's looking good. 73 degrees is what it registers, and that's probably correct. It's cooling down here today in Atlanta. And so that is all but one last thing, and that is I had to figure out how to get an electrical connection to the outside. I have the electrical connection to the inside, to the stainless steel tube, the 1 3/4 stainless steel tube that is floating in position, but I needed to have also a electrical connection on the outside. And rather than trying to weld on this thing, I just went ahead and used the electrical connection here that is provided by the bolts to the base unit, and that's the aluminum block down at the bottom. So I just built just a little electrical device here. There it is. I'll probably put it over here. Probably looks a little better. And so that'll just go down with a washer and a nut. And that's a good fit. And then I used the voltmeter, and I tested ohms. I got really good connection. I got continuity from here all the way to the actual base canister itself. So I know that the electricity is going to flow very nicely there. Okay, and then of course I got the other washers and nuts for the unit. washer and nut, and washer and nut. I probably could get wing nuts on this, but it's not a big deal. Next time I'm up to Home Depot, maybe I'll pick up some 5/16 wings. Okay, so there we go. There is the unit and its glory. And this can be cranked down, and I'll probably I'll put about 10 pounds of pressure on each one of these in a nice organized way. There's the thermometer reading, now it's up to 74, and I'll be able to get a good connection on these two here, a positive and a negative. We actually introduce a very small amount of current. I mean, it's like 2 milliamps. It's just enough to upset the aluminum and continue to strip off the oxide, oxidation on the aluminum, and that keeps the chemical reaction going so that they can split the water. Okay, and produce the hydrogen, and the oxygen finds itself attached to aluminum and becomes aluminum hydroxide. And over a period of time, we can dry it out, and it becomes aluminum oxide, which can be recycled back into the aluminum process to be made back into aluminum, along with aluminum cans and other aluminum products. Okay, that's it. So this is the HODCELL, and it's 7.5 inches tall, and maybe a little more if you include the base. Let's get a measurement on that. Let's see here. Yeah, so I'm going to add, let's see, 7.5 plus the stick itself is another half. I'm going to say that's 7 3/4. So just about 7 3/4 tall, maybe 7 7/8, and it's 6 by 6 wide. And the canister opening is 5 inches. We have a pretty good seal, and so I'm going to go ahead and button it up now and then begin some experiments. Thanks for watching. This is HODPod signing out.